Hello. So now we're going to look at number 10, okay? So number 10. Okay, so a 2.5 kg block and a 0.75 kg block are both attached to an ideal spring for which K equals 250, and both are initially at rest on a horizontal frictionless surface as shown above. In the experiment, a 0.2 kg piece of clay is thrown at the 2.5 kg block. The clay is moving horizontally with the speed v, and then hits to and sticks to the block. The 7.5 kg block is still held by a removable stopper. As a result, the spring compresses a maximum distance of 0.3 meters. A. Calculate the energy stored in the spring at a maximum compression. Okay, so let's go ahead and look at A. Okay, so for A, we don't know the initial velocity of the clay, and we don't know the final velocity of both the clay and the block. So what that means is there's no way for me to be able to actually find one of those without the other. Okay, so what I need to do is I need to find one of those in another manner so that I can then use momentum. Okay, so right now I can't use momentum yet. Okay, so I need to use something else. In fact, it tells me I need to find the energy, right? So I'm going to use energy of a spring, so PES equals 1/2 kx squared, right? So it's just 1/2 k, which is 250, times x squared, which is 0.3 squared. So I can go ahead and type that into my calculator. And that gives us 11.25 joules. Remember to add that unit, okay? So that would be my answer. Not too difficult. Okay. Next, it says calculate the speed of the clay ball and the 2.5 kg block immediately after the clay sticks to the block before the spring compresses significantly. Okay, so this is part B, and so this is another energy question, right? We found that, and so we have our EI is equal to our EF. So our initial is just kinetic energy because the spring is not yet compressed, and then at the end, that's the complete distance it compresses, which means it's no longer moving at that point, right? If it was still moving, it would continue to be compressed. So we're just left with this PES. So we have 1/2 mv squared equals, and then our PES is just the number we already found, 11.25 joules. Okay, so 1/2 times the mass we have now is the mass of the 2.5 block plus the mass of that piece of clay. Okay, so that would be 2.5 plus 0.2, that's my clay, v squared equals 11.25. Okay, so I'll multiply both sides by 2, so I get 22.5 equals 2.7 v squared. Go ahead and divide by 2.7. So v squared equals 8.3, repeating, and then I'll take the square root of both sides. So I have v equals 2.89 meters per second. Okay, so not too bad so far. Let's go ahead and move on to part C. Okay, so part C says calculate the initial speed v of the clay. So now we know that final velocity, which means we actually can use momentum. Okay, so just set up momentum. The total momentum at the beginning is equal to the total momentum at the end. Now we only have one object moving at the beginning. And then at the end, we have those two objects stuck together. So we have m plus m, vf, okay? Now we know this vf here is the same as that, okay? And then we also know everything. So we have 0.2 vi is equal to 2.5 plus 0.2, and then times 2.89, okay? So I have 0.2 vi equals 2.7 times 2.89. This might be a good point to try to use your original values, but it won't end up mattering too much. Okay, and then I just need to divide by 0.2, this is my VI, and so I get 39.02 meters per second. Okay, and so that is, whoops, let me undo that. So that is just my final or initial velocity of that clay blob. okay? And so that's just a momentum question. Let's go ahead and look at part D. State. So in a second experiment, an identical piece of clay is thrown at another identical 2.5 kg block, but this time the stop is removed so that the 7.5 kg block is free to move. State whether the maximum compression of the spring will be greater than, equal to, or less than 0.3 meters. Okay, so remember, if you're ever trying to explain something, what method should you use? Energy is always a great place to start. So this is an explanation question, but I'm going to start with an equation to then show where my ideas are coming from. Okay, so at the beginning, I just have kinetic energy of the clay plus the smaller block. So I'll put lowercase b. Okay, and then at the end, I'm going to have the kinetic energy. At the end, I'm going to have the potential energy of the spring, but now I'm also going to have a kinetic energy of the whole system, right? Because this whole thing is going to end up moving forward, okay? We're going to end up moving this whole thing forward, right? This whole section here has to move forward because there's nothing stopping it, right? And so it's almost this momentum question with the whole thing, okay? So that whole thing is going to move forward, so I need a plus kinetic energy of the system. Well, since I'm starting with the same amount of energy on the left for both, right, the KE initial is equal to the KE initial of the first one, right? Which means now I have to split this with the spring and with the kinetic energy of the system, which means that the compression will be less, okay? Now, I would suggest writing a little bit more, but since you have my audio, that's kind of my explanation there. But it should be less because the kinetic energy initial is now split between the energy of the spring and the KE of the system. This will reduce the energy of the spring, which means it will compress less. Okay? So that is number 10. This is maybe a little bit of an easier question. It helps guide you through some of this stuff. Once again, if you ever have a question, let me know. Thanks.